All right, looks like we're back again another week doing a live stream for DGX Spark to the developer community here. This time, not just NVIDIA on the stream, but we've actually brought some friends who have been working with the Spark for a long time, going to share some goodness with the community so you guys can learn some things. As always, we're open to taking questions from you during the live stream, so make sure you put those in the comments, in the chat. We'll try to make sure we get to everybody's comments. And please make sure you also mention in the chat where you're joining us from today, because we love seeing how global the community is. So joining us today, we've got the talented folks from Canonical, and I want to give them a chance first to introduce themselves. So Abdelrahman and Farshid, please, let's do the introductions.
Thank you, Mark, for hosting us today. My name is Abdelrahman, and I work as a Silicon Alliances Manager at Canonical. We basically try to make every silicon on Earth happen on Ubuntu. That's what we do.
Amazing, amazing. And Farshid, do you want to introduce yourself?
Hi, I'm an engineer manager at Canonical, and I work on industrial and edge AI.
I love it.
Thanks
I love
for having us.
So happy that you guys are here. And I think, you know, just thinking about edge AI applications, the portability of applications, you know, this is right in the sweet spot of what Spark is able to serve for so many folks. And, you know, over the last 6-7 weeks, we've been getting so much great feedback from the users. But I hear today, rather than me being the guy with all the logos on and looking like I'm a walking billboard, you're going to actually show some real demos today and give some overview of the work that you've been doing. So without further ado, I think we should jump right into the content. That way people will know what they should be asking questions about. So Zach, do you want to bring up the presentation that the guys have here? And I'm going to say hi. Wow, we got lots of people joining us. We got St. Louis, Missouri, Switzerland, Netherlands, Kazakhstan, Georgia. Man, a lot of people should be sleeping right now. This is great. Thanks for joining us, everybody. All right, well, I'm going to turn it over to Abdelrahman and walk through our presentation.
Great. Can you see the slides here?
We can see the slides.
Great. Today I'll be talking about back-end development with local LLM Inference. And it's basically telling you my story with AI development bottlenecks and how we go from AI services to embedding AI applications, and why DGX Spark came to the rescue of our missions, and the local inference scheme, and then we will jump into live demos. So it all started a few months back when one of my team members was saying, I need an API key for testing for one of the LLM providers. And as a good manager, I said, sure, yeah, here you go. There is an API key. And I forgot to put some limits on the key. And they used it for testing, but they also added it to the CI/CD pipeline.
Oh.
So running dozens of tests every day on that. And I got a surprise bill. It wasn't much. It was exactly that number, $206.
Oh, wow.
It's not much, but it's bothering me. Like, if you are spending that much just for pipeline development and testing, how much it's going to cost us for the production? And there must be a better way to do that. And I think everyone over the past year or two have been building AI apps using this scheme, where you have an AI service, say any other big lab providing a big model, and then you build your app subscribing to that API, you call this over the network, and you get your inference, and this is how we build apps until today. Mm-hmm. But over the past year, there has been a scheme where people are trying to embed AI inside their apps instead of depending on external services. And the reason for that is not every application needs a big reasoning model. You might just want a small 1 billion parameter model, or even smaller. Or you might want a slightly bigger model that does the job well for you. It's cheap, it's fast, and it runs. Whether this runs on the same client machine or runs on the server, people are recognizing that embedding AI within apps as a component is actually serving them well, instead of depending on distributed system kind of network calls and the cost that comes with it.
Right.
But that comes with a challenge, right? Because deploying AI within apps is not easy. It's not a straightforward task. It's not like a function that you code or a standard library that you code. There's a lot of components that comes into AI to make your AI app just as wonderful as you want. And the questions that we always say is like, how can we set up the environment such that we embed AI within an app instead of depending on external service? How can we use local inference for that purpose?
Mhm.
And if we can do that on data centers or clouds, can we do this on the client machine? And yes, we can. We can do both. But going from the client machine to a production data center with inference is actually a little bit tricky. And this is where the DGX Spark come to answer a few important questions for our community. First one is, how can we go from development to production? If I'm developing local AI inference or fine-tuning or whatever I'm doing on AI, how can I go from dev to production? Can we unify the stack? The good news is, yes, because DGX Spark runs Ubuntu. It has the CUDA software system. It supports the different inference engines for the ARM architecture. And you can actually do local inference on the DGX Spark the same way you are going to take that same application to production on the cloud. The second question we get is like, okay, I'm doing this local inference with my DGX Spark. Am I being productive, or is it actually slower than going out for a network call and making an API request for one of the big model providers? And the good news is, this is faster than network. DGX Spark, as you all know, has a 20-core ARM. It has a Grace Blackwell 10 GPU, a lot of petaflops, and we'll see today on the live demo that it is so productive to just do local development and take the same thing to production. And then the question is it complex to do so? Because we value developer time, probably, or I hope so. So we don't want to complicate our environments. And what comes to the rescue here is, since this is Ubuntu and we can support containerization, Olama, VLM, and other open source and Triton runtime of other open source inference engines are working there. And there is silicon orchestration that is happening to optimize for the GPUs and whether to run this on the GPU or maybe some inference that runs on the CPU.
Yeah, and I think I was just going to add to there, Abdul, when you talk about moving from dev to production, and you've noted that it's using the Grace Blackwell architecture. So as you start looking at your MLOps, when people are training their models to be optimized for Grace Blackwell, this is really just scaling up from this point. So it's really a great starting place for them.
Exactly. Yeah, and then with that story, the question that I got afterwards, after like experimenting with some local inference before the DGX Spark, is like, can we just install AI? Can we just do like apt install or yum install or pip install or conda install a name of the model and it just works? And that's what we exactly have been working on, and Farshid and his team has been working on for some time, trying to figure out what does it take for that simple one command to probably work, and we will make it to work. And that's when we introduced Inference Snaps in Ubuntu Summit a couple months ago. Inference Snaps is the way that we package open source models and make it easy for people to use and deploy locally and on the servers as well. So what we do here is we actually work with the silicon layer to optimize the models for the different silicon that we run on. And we do the packaging, the distribution, the dependency management, model architectures. There are runtime engines, the API standards, the optimizations that are done for the CPU, for the GPU, and the different silicon that we have, with the goal that it becomes easy for us developers to do app.generate, choose the model and the modality that you want to generate from, and it just works. And you don't need to worry about how to actually install it, how to ship it on the client machine, how to manage the dependency. And if there is a newer model available, it becomes easy for you to update the model without going like crazy on like, where is the new model coming from and how we download it and how we set it up. And that's the idea. Today, if you have Ubuntu machine, and especially a DGX Spark machine that is so fast, and you do a sudo snap installed Gemma 3, you will get the Gemma 3 model running locally and start building on top of that model immediately. And this is the demo time.
The favorite part that everyone that loves to get to is actually seeing it work.
Yep. Any questions before we jump while I share my screen to the demo?
I think we've had lots of questions. Some people have been asking about stacking the Sparks and experience with that. Some folks have been been talking about, advantages of running locally. So, I would just say to a few people that are out there that have asked about stacking the Sparks, we've had other live streams. If you look at the DGX Spark playlist, we've talked about stacking them. But yes, you can stack multiple Sparks together. Currently, our documents support 2, but we're not saying that you can't stack more. It's just the documents right now support 2.
Yeah. And the reasons to do local development, other than the $200 that I didn't want to pay for CI/CD pipeline, it's the joy that you get actually from seeing models running locally and owning that infrastructure afterwards. Open source models are great. They come at different sizes and they have different use cases. NVIDIA publishes a lot of open source models. Like last week, it was like the VLA model, the Vision Language Action model, which is great. You can actually do a lot of work with these models. So it's owning that piece of compute within your application that makes it very appealing, at least to me.
Absolutely. And the security factor of just keeping it local, keeping it edge.
Exactly.
All right.
And for the security, that's what we're going to discuss today, actually.
All right.
Can you see my window here?
We can, yes.
Okay, great. So what I showed you is the sudo snap install Gemma 3. And this is going to say this is already installed because I installed it beforehand, because it takes some time to download the weights of the model. So I did it before the live stream. And what you can see here is if you do Gemma 3 status, you can see that this snap is running on the NVIDIA GPU ARM64, which means that this open source model was optimized for this NVIDIA GPU, which runs on the DGX Spark, and it offers you a local host endpoint that you can run. And I'm going to show you an app that we built on top of that. But just testing the snap on your machine, if you do Gemma 3 chat, and it opens up a chat interface, it tells you that it's connected to the local host, and you can type a prompt, and we can do the classic prompt of why the sky is blue. You can see it's so fast. It's actually faster than my other server clients streaming. This is so long, so make it brief. It keeps the chat there. Here is a brief explanation of why the sky is blue, and I'm happy. This snap is working, but I can get the same result with Olama or VLM, and like I can do a Docker run as well for this model. What makes this so special is you can now build apps on top of that dependency. You can ship complete apps that know that Gemma 3 runs on the machine, and it runs on all machines. Like if there is no GPU available, it's going to use the CPU. If there is other accelerators available, it's going to use that silicon optimized. But of course, here we have been seeing the great performance from the DGX Spark. So how can we build an app on top of that? That's this app that I have. I have a snap. I have an app called Chat. This is a Python file. I'm going to go over that file. It's a very simple file here. So it mainly starts by reading snap data so that it gets the JSON file called the status that we just saw when we did Gemma 3 status. It gives us the endpoint. The reason for that is you want to get the URL here, which is the endpoint that this snap offers to you. And then from that endpoint, your existing code that works with OpenAI or any provider, you can use the exact same code. The only thing that you change is you've changed the URL, and you don't need an API key because this is running locally on your machine. Right. Then this you have the models, the model list, and you get the model name that is available because you might have multiple snaps running on the same machine, multiple models, each running its own URL. So you can query that and know which model that you want, which model you want to use from that endpoint. And it's the same code where you have streaming. It's creating the messages, the content, and then printing it out. This is obviously just a simple chat application similar to what I have just shown you, just using that local inference endpoint.
Right.
And when I build it, I just do a snapcraft build. I put that command in a make file. The repo is going to be available online, so you don't need to worry about what I'm showing you here. But I'm doing a Snapcraft build for building, and then I'm installing the Snap, connecting it to Gemma, and this is how we are testing it. So if I'm doing a make build here, that's
You're getting a lot of compliments in the chat, Abdurrahman. There's people are saying this is awesome. It's pretty cool. I think you're helping some people out today.
Oh, great. I'll be available to help afterwards as well. Rashid is here as well. So when I do make build here, this is giving me a classic error, and I'm happy that it showed up on the screen, so we have it for documentation. How we solve it. It's mainly adding my user. When you see this error, it's adding my user to the LXD group. So we do that, and then make sure that the permissions apply, and then I do make build again. So this is building the project, launching the instance to build the project. The project is cached, so it's not going to take a lot of time to build. So here it's building for source, restaging, priming, and we have a build package. It's packed here in this file that we can simply install. When I do make install, this make install is mainly installing that snap here that I had locally. So doing the snap install, and we get the command called demo app that we have. But before the demo app, I want to show you the test, because the test here, what it's doing is it's doing a curl over this chat URL so that we see the tokens per second here. So that's some real life kind of testing here. It sent a prompt, and it's amazing 70 something, between 70 to 80 tokens per second. And that's just the first kind of optimizations that we did with that model on the DGX Spark. It's more optimizations can come, and we can have better caching, and we can have more tokens per second presented in here. But to try my app, it's the demo app here. This is the command that I ran, which is basically executing this Python file that we have. This is the response. It's using the endpoint and so on. But then I felt like, okay, building a chat app on top of the endpoint, that's boring, or that's what we have been doing. Or as some of my friends say, chat applications are so 2022. We are now in 2025.
You hear that, everyone. It's still viable. It's still viable, but you know.
Yeah, but it's funny because we are now seeing apps treating AI as like truly part of the application that you feel some magic happening in the background that you're not seeing how it happens. The other app that I built here, and I can't claim that I built it. I actually give ChatGPT the code for the chat, and I asked it to modify it to read a local PDF file that is sensitive. It has sensitive information. I don't want to send it out, and I want to summarize this file. This file could be a meeting notes, could be some file on my machine. And a lot of people who have been building RAG systems over the past years are probably aware of these PyPDF packages that read the PDF. It extracts the PDF text, and then from this extraction, it's the same code. Basically, after you extract the text, you give it a system prompt. You're an assistant, summarizing documents and removing redundancy. Summarize this PDF document. So I got a Thor document, the Thor kind of file for the Jetson Thor from NVIDIA. I'm not sure it's going to show up here. The PDF file is not going probably to show up here on my VS Code. But this is the file that is describing. I can show it to you when I get back to the slide. That is describing the specs for the Jetson Thor, which also runs the snaps and runs the same thing.
Well, you just answered somebody's. There was a few questions in the chat that people said, "Does this also work on Thor?"
Yep. It's the ARM architecture and it works. You can try it out, and if it doesn't work, let us know. We will be able to help. So if I do a PDF summarizer, just to show you the code, that's the code that I have been showing you This is the summarizer, the system prompt that summarizing the PDF document, and the makefile is the same makefile, and I already built it. So it's PDF summarizer, summarize this Thor file. This is all running locally. Yeah, Thor is now public. There is no confidential information here, but here is a summary of the NVIDIA Jetson Thor PDF. Introduces the Jetson Thor, high-performance platform for physical AI, which is great. And there are key features here and the specs from the document. But what I wanted to show here basically is that idea of you have some code, and that code, instead of calling some external dependency, that code can call some model that is packaged within the same snap file. So a snap can depend on other snaps, and this is a packaging scheme. And the closest thing that you can think about it is when doing mobile development for Android or iOS, and you have some system level interfaces for the libraries that are available on these platforms. This is very similar. You have snaps available on Ubuntu platforms, which is DGX Spark and it's Jetson Thor, and which is most of the AI cloud servers are running on Ubuntu. And if you have that layer of dependency, then you can package more of your apps with these snaps in place and make it available to use. And both of these demos will be available on GitHub, so don't worry about them. But I will go back to my slides and leave time for questions, and if actually people want to see more fun stuff, we can do. But here it's some tutorials. If you Google Inference snaps, you'll find them on the Ubuntu. This is all open source. Both the models that we actually package and publish are open source, and the template that we use to package these snaps, because packaging these models as a snap is just using the snap craft. So everything is open source here, GitHub, if you want to contribute to the inference snaps. And if you have a favorite open source model, right now we have Gemma 3, Qwen 2.5, and DeepSeek R1. And we are working on more models and more silicon optimizations. So you can try out and let us know in the GitHub discussions what you think.
That's great. Thank you so much. That was wonderful as a demo, and I'm glad we had the URLs up there for a minute or two for folks to be able to get. Yeah, they're there. They're back up again, just so that folks can grab those, because we definitely see a lot of folks traffic and starring repos after they watch the live streams. One of the questions people had was just, I think it was a surface level question, but which version of Gemma were you using for the demo? Do you know?
Farshid. This is Gemma 3, but I asked Farshid.
This is Gemma 3, and the quantization that you get on the size of the model depends on the underlying system. So we are now starting with the smaller ones, but the idea is if you have a beefy machine with a lot of VRAM, you are going to automatically get something larger, but you can switch to different quantization if you want.
Right. Yeah, absolutely. And I think that's one thing. I saw some demos from a member of the community this last week, and that was one of their points about building on Spark in this way, is just there's so much RAM and the ability to run multiple models at the same time. So when you can speed up a workflow like this, you're truly taking advantage of the system. Let's see what other questions we have in here. And so someone asked, I think you might have covered this, but they said, will the inference snaps be containerized?
Yeah, I can take that. So snaps are a form of containerization. They are confined in their own environment. The network is shared with the host, but everything else, the dependencies, the access to the different devices and resources are all confined. So whether you call it a packaging or a containerization format, it is confined.
Got it. Okay. And that's ultimately because you're containerizing it in this way. That's what's allowing you to speed up the workflow so much. Yeah, absolutely.
If you can show the screen again, I will show quickly. This is when I do the Gemma 3 show engine for the question of we want to see which model and which engine this is using and which runtime this is using. If you do Gemma 3, it's using the NVIDIA GPU ARM, and this is the criteria that it used to detect that it needs to download the runtime and the model for that. and this is how much disk space it's using, and the memory. You can always remove the snap. You can always stop the snap. You can always start it. That's completely within the Snap ecosystem.
Yeah. So one thing that Abdurrahman, maybe you forgot to get into is if you develop an app on top of these, when you install that app, the dependency gets automatically installed. So as an end user of this application, you don't need to worry about installing Gemma, picking the right quantization, picking the right runtime. You just install your, I don't know, PDF summarizer, and the dependency gets automatically installed. During the installation, it detects what device are you on, how much resources do you have, and then it automatically installs the relevant things. And you don't need to worry about any of it. You can still customize it afterwards, but by default, you get something that works, with decent performance.
This is what Farshid is showing, like how to specify this as a dependency. This is a plugs within the Snapcraft file that you say, I want to use the Gemma 3 as a provider for that plug. And this is how you specify the dependency. For the other PDF summarizer, it's the same thing. It's the same Gemma 3. The only thing is I added another Python package as a dependency here, and I give it access to the home directory so that it reads the file from the home directory.
All right. There was another question about the snap saying, it's not a very full question, but I'm going to ask it anyway. Are snaps start and stoppable?
Absolutely. Yeah. Snap stop. Snap start.
It's just as easy as that.
Yeah.
All right. Perfect. Just want to make sure. And then what are your thoughts about the Spark with regards to MLOps? Like, where do you see this in the workflow? Where do you see this in the general nature of the projects you've been working on? I think, there's been a lot of confusion in the community of, do I think of this as, my tiny little inference box? Do I think of this as my training engine? Where do you see this across the MLOps workflow?
I would answer, and Farshid, please add if you want to add anything. The way I see this is a small production environment on your disk. That's exactly it. It's the same software stack. It's a huge capability for the GPU on your desk. And what it means is you can unify your development environment, your testing environment, and the production environment in there. And the nice thing about it is some people were saying, like, okay, the Spark is a small little machine on the desk, so I have to be with it all the time, connected to a monitor. What I'm showing here is this Spark is actually sitting on my desk, but not besides me. It's sitting on my desk somewhere else.
Right.
On another place, and I'm just using it as the same thing. So I can use the same Spark as part of my CI/CD pipeline if I want, if it's reasonable, and that's the true value that I see. It's like doing inference, yes, doing fine tuning. You don't need to wait for a container from some of the services, or just book a server and install the dependencies and wait for times to get the GPU. It's in there. So that's how I summarize. I'm not sure, Farshid, if you want to add anything.
Yeah.
I think you covered it.
Yeah, and I think you actually brought something up there, the fact that you don't have the device next to you. I know some folks were asking me in some of the community forums earlier this week, do I have to be plugged into it? Do I need any kind of special cabling for this? Is it Ethernet? Is it USB-C? Obviously, you can do this completely wirelessly, but you made the point about it being not on the desk next to you. And some folks have thought, well, I just need to have this in my backpack with me when I'm traveling with my laptop. But it's not just that you could have it remote. You can actually have team members collaborate on this in its local environment and SSH in or access maybe via like Cloudflare or similar, right? Have you guys experimented with collaborating multiple people on the Spark remotely?
This is exactly our setup right now. Well,
okay.
I would say the Spark machine is very light and it's nice to carry in the backpack, especially like it looks nice. But because we are multiple people working on that DGX Spark, it's actually sitting on a desk, and we use Tailscale for tunneling to it. And it's so easy. It's like Tailscale, everyone is getting on the same VPN, and every one of us has their own user account, their own home directory, so we do our own things in there. Of course, we don't do heavy kind of training or right now, but if we do heavy training, we need to do some coordination amongst ourselves that someone is occupying the GPU.
Yeah, and that's probably a key point as well, is this isn't really, intended to replace somebody's laptop or their small workstation, right? It's, in fact, the ability to run some of these powerful levels of computation and not brick the machine that you're checking your email on and you're doing your day-to-day Slack on and the collaboration you're having with your team members. It's the fact that you can still run these things locally and collaborate with others while also having your main workstation. You certainly can use a Spark as the workstation, but what we're seeing is members of the community really just recognizing that offloading that power while not having to have, I think you had the $200 single, $207 single use from your team member, not feeling like there's a black box on what's happening with inference costs that are happening remotely, right? Especially when you're in such an early stage production environment.
Exactly. Yeah.
Let's see. There's some folks in here. Someone asked about fine tuning with Spark. I don't know if you guys have experimented with any of that.
Not yet, but I have been seeing some people online trying that out. And I would say that the only difference with Spark versus a server is basically the CPU architecture, not the GPU architecture. The GPU architecture is going to be the same, but the CPU here is ARM, and on a server it's mostly x86, and that's when some of the libraries are not compiled yet for ARM, and that's where some people might find some of it not working. So it depends on the library. We haven't ourselves experimented yet with fine tuning on the DGX Spark, but it's on our roadmap.
Awesome. Yeah, we've have some partners in the seed program. I hope to have them on here soon, but some of the folks from Prime Intellect and others are experimenting with various training methodologies on the Spark. And I know we have a hackathon coming up in Austin, Texas next weekend that's actually teams building exclusively on the DGX Spark. So I'm hoping there's going to be some fine tuning and some lures that come out of that activation as well. Let's see, what other ones do we have that are just popping in here real quick? I know we're coming up on time. A few people have asked about cooling. This is more of a product question, but I'll try to just make sure I can answer that real quick. The Spark has been running for literally dozens to hundreds of hours for people. No major issue have been happening there. It's designed from an industrial design standpoint in a way that natural airflow happens, and you've got the stand itself lifting it off the surface. We've even seen people stacking the Sparks on top of each other. So no issues there whatsoever for anyone. And it's running off standard power supply. So literally when we mentioned, everyone mentions that you can just throw this in your backpack and take it somewhere with you, you're not going to have any issues with your power supply. Someone asked, what is the seed program as well? So we had an early access seed program where there were a number of partners that were chosen to have early access to the Spark so that we could develop the product and we could learn more about that. So if you're the sort of startup or company that's doing some really innovative things and you want to be included in that, make sure you join the community and let us know what you're working on. You can always tag us, or you can email us, community@nvidia.com. We'd love to learn what folks are building. So let's see. There is one more question here. How do you handle model versioning and experiment tracking when working locally on DGX Spark before deploying to a cloud infrastructure? So kind of an intellectual question about workflow, but I'll offer that to our guests. What are you guys' thoughts about this?
Firstly, do you want to take this one?
So depends on your deployment method, but if the models are snaps, then there is a versioning and tracking mechanism. So snaps have a concept of channels that are identifiers that you track, and then you can track a measure, you can track based on risk level, and you can also track based on development branches. You get automatic updates, and as long as this is in a working state, you can carry that forward to your cloud, following the same tracking mechanism.
Got it. Awesome. And then I'm going to address this one. So Janine, you asked a question here that said, is there a potential risk of hacking from agentic AIs on the DGX Spark compared to agentic AIs on the cloud? I don't want to go too deep down that rabbit hole, but there was recently announcements about the security updates on the Spark with an update to the system. I would recommend checking that out on the Spark page and in our forums. But we just had a major update on security. So no major concerns there whatsoever. And okay, I think with that, we're coming up on time. Is there anything else? I guess I'm going to do the guest host thing. What's next for Canonical? What are you guys working on right now? Is there more to come from you with regards to Spark? What's the update from your org?
Yeah, so for the Inference to Snap project, we have a very interesting roadmap ahead of us for both supporting more open weights, open source models, and more silicon optimizations in there. So we're engaging with the community to see more of what models the community wants to see on the Snap, so that Canonical supports these models, deploying them in edge and client and server and providing the security fixes and so on. And from the silicon optimization point of view, this is a big part of it, because we want to make sure that the models run smoothly on every silicon that runs Ubuntu. Ubuntu is there already, everything. So that's regarding the Inference Snaps, and we'd be excited to hear the feedback. How are people using Inference Snaps, and if more optimization is needed.
Perfect. Well, I'm going to invite everybody in our community to go join your Git repo and make sure that they star it. And then they try running it themselves, make sure that they're contributing to your PRs and adding to your notebooks and giving feedback. That, all of these things get better when it is a community effort all around. So with that, I'll say thank you to our guests from Canonical for joining us today. As always, the team will look at some of these comments after the stream and try to make sure we answer and address any requests for links and more that maybe we didn't get to today. But gentlemen, thank you so much for joining us and giving us your time. And I hope we can have you back on again to show updates to the project.
Sure. Thank you so much.
All right. Everyone have a great rest of your weekend, and go build something. All right. Thanks, everybody.
Bye.